Let me show you a general procedure for dealing with complex rational expressions. And let's do it with this complex expression right here. Let's start by finding the LCD of these four terms. So we know that the LCD here is, let's write it down here, x squared y squared, right? X appears here and it appears here, but to the second power, so we know we use the higher power. Y appears here, but to the second power here, so we know we use the higher power. So there's our LCD. I'm going to circle that so we don't lose it. Now here's how we're going to do this. Here's the general idea. What we're going to do is we're going to take our original expression, and I'll rewrite it over here, and what we're going to do is we're going to multiply this by 1. Now multiplying by 1 we know does not change the value, but the one that we're going to look at is this. We are going to write this 1 like this. We're going to write it as LCD over LCD. And in our case, the LCD is, now we have it right over here. Right, here's our LCD. Our LCD is x squared y squared, so x squared y squared. And now we know how to multiply these fractions. What we're going to do here is multiply the tops together. We'll multiply the bottoms together. And what we're going to do is just indicate it here. So let's multiply these tops together and these denominators together. So let's do this by indicating the multiplication. We'll take this left top, 1 over x squared plus 1 over y squared times the right top, x squared y squared, and do the same indication with the bottom. We'll have 1 over x minus 1 over y. We're going to multiply that by x squared y squared. Now let's take this all the way up to the top here, and what we're going to do, of course, is we're going to use the distributive property and distribute through. So this will give us, let's see if we can get this thing to right, 1 over x squared times x squared y squared plus 1 over y squared times x squared y squared. And all of this is over 1 over x times x squared y squared minus 1 over y times x squared y squared. Now, here's what I want us to look at here. You see this LCD back here, right? So we started with our original expression, we got the LCD. And then what we did is we multiplied the original expression by 1, but the 1 is in the form of the LCD over the LCD. Here it is. We distributed the LCD to the top and the bottom, and look where that LCD ends up. The LCD ends up right here next to the first term, right here next to the second term in the top, right here in the first term in the bottom, and right here in the second term in the bottom. So the LCD ends up, right, our original LCD ends up here, 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 and here. That is, the LCD ends up right next to all of the original terms. So when I do these problems from here on, I'm just going to start with the original expression right here, whatever it may be, get the LCD, and then the next step, I'm just going to write that LCD right next to each one of the original terms. I'm not going to go through all of this anymore. So let's do this multiplication. You can see that this x squared here will cancel with this x squared, and we are left with 1 times y squared. So let's just write that. 1 times y squared is y squared. And then we've got plus, so we'll write the plus. And then we've got that y squared here canceling with this y squared. So we're left with 1 times x squared. So we'll write that. 1 times x squared is x squared. And now in the bottom, we have that this 1x here will cancel with one of these two, right? So this one here will cancel with one of those two, leaving us with 1 times x times y squared. So we'll write that. So we're left with 1 times xy squared, or just xy squared. And then a minus. You can see over here, this 1y will cancel with one of these two y's up here. And so we're going to be left with 1 times x squared y. So 1x squared y, that's just going to be x squared y. Now, we've got this rational expression, simpler than the original. So we always try to reduce the rational expression so we can factor this denominator. So let's do this. Let's factor, I got an x common and a y column. So let's factor out an xy. So the numerator is going to be y squared plus x squared. And the denominator, now we're going to factor out that xy. And when we do this, what we're going to be left with in here, right, we had an xy squared. We factor out an x and a y. So we had an x. We took it out. We had two y's. We took one out. So we're going to be left with one y. And then a minus sign. Right, this minus sign right here. Oh, I didn't mean to do that. And then we're going to factor out that xy, so we're going to have what's left. Well, we had two x's to begin with. We took out one, so we'll have an x left. We had a y, but we took that out, so all that's left here is going to be that x. And I think we've got it. Nothing's going to cancel, so we've got this thing simplified. Now, in the top, if you wanted to, this y squared plus x squared, since addition is commutative, we could switch the order. And some of us just like to write these things in alphabetical order. So we could write this as x squared plus y squared over xy times, I'm going to still leave it y minus x. There's something we can do there, but we don't need to do it here. All right, so let's just go through it quickly. And here's the general procedure. You start with some complex fraction. You find the LCD. You write the LCD right next to each original term, because what does it do? You multiply, you distribute, so it ends up next to each original term. Then what you do is you cancel all the common factors, and the denominators in the top and the bottom will cancel out. And then you factor or try to reduce what's left.